right, good to see you again. See you through a camera, but that's okay. Today we're doing Unit 2, Lesson 11, Interpreting Graphs of Proportional Relationships. And our learning goal is, let's read stories from the graphs of proportional relationships. And let's kind of review for a minute here. Remember, a graph to be in a proportional relationship has to be linear, which means it's in a line. The points are in a line. And it has to go through the point of origin. So if we look at this first graph here, is it proportional? Yes, it is linear. And it goes through the point of origin, which is 0, 0. So it says, here is a graph that represents a proportional relationship. Invent a situation that could be represented by this graph. So I want you to stop the video and I want you to come up with what could the story be here. Then you're going to label the axes with the quantities in your situation and give the graph a title. So stop the video and do that. All right, so what I came up with was, I said this was the number of strawberries. My x-axis. My y-axis is calories. So my title is Calories and Strawberries. So as I eat strawberries, my calories increase as well. All right. Apparently it didn't print on both sides this time. All right. There is a point on the graph. What is its coordinate and what does it represent in your situation? I left that out. Okay, so this point right here, if we do x first, this is at 16, 12. And in my story, that means 16 strawberries have 12 calories. All right, so in your story, what does that 16 represent? And then what does that 12 represent? All right, so now to the next page. Turn some pages here. Okay, now we're doing Tyler. Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. The point on the graph shows his arrival at the bumper cars. What do the coordinates of the point tell us about the situation? Okay, so this is the point right here they're talking about. 40 is our x. What does our x-axis represent? Okay, 40 seconds. So 40 seconds. Now what does our y represent? This 50 represents the distance from the ticket booth in meters. So 40 seconds. It took Tyler 40 seconds to go 50 meters from the ticket booth. All right. The table representing Tyler's walk shows other values of time and distance. Complete the table. Next, plot the points on this grid. All right. So if we look at it, so if you go to the next page, you're going to see, come on, make my fingers work. We've got this table right here, so I'm going to stay on this page and I'm going to graph it. So we had 20, first we had 0, 0. Okay, so we're going to graph 0, 0. Then we had 20, 25. So 20, 25 is right in between there. So that's 20, 25. This is 0, 0 right here. All right, and then we had 30 and 37.5. So here's 30, 37.5 is right in the middle here. So that's 30 comma 37.5. And I think that's all we had. Oh, 40, 50 we already have. Okay. So we plotted them on the grid. What does the 0, 0 mean in this situation? Well, 0, the first 0 represents the seconds. The second 0 represents the meters. So that means in 0 seconds, he went 0 meters. At 0 seconds, Tyler walked 0 meters. How far away from the ticket booth was Tyler after 1 second? So seconds is our X column, so that's why we put 1 there. Now how are we going to figure out this number? Oh, let's think about it. Is this our unit rate? Is this our COP? So can I come over here and do Y over X and do 25 divided by 20, which would give me 1 and 5/20, which would give me 1 1/4. So this is going to be 1 1/4 or 1.25 if I want to write it as decimal, which is kind of easier. All right, so how far away from the ticket booth was Tyler after 1 second? He was 1 25 meters away, and then they want us to graph that. And that's going to be a little tricky because this is 5, so 1's going to be here, and it's going to be about here. So this would be 1 comma 1.25. Now, that represents what? What is that 1.25? That is our COP, okay? So what is the constant of proportionality for the relationship between time and distance? The COP equals 1.25. Now, what does that tell us about Tyler's walk? That tells us that at 1 second, he is at 1.25 meters away from the ticket booth, but it tells us he's walking at a rate of 1 1/4 meters per second. And where do we find that on the graph? We find that on the graph, let me get the right graph. We find that on the graph where X equals 1. So the COP is where X equals 1. Oh, I've said that before in a table. The COP is where, or when, X equals 1. So here, that's the value in the table. On the graph, it is when X, the X coordinate is 1, whatever the Y is. So if I was to draw this line with a straight edge, which I don't have with me right now, that point would be on the line. And that means at 1 second, he would be 1.25 meters away from the ticket booth. And that is his COP. All right. If Tyler wanted to get to the bumper cars in half the time, how would the graph representing his walk change? Half the time. Well, let's think about that. What if we come and we make a table? We do the time and the distance again, just so we can see it. He's still 0 seconds, he's going to be 0. But at half the time. So let's half the time. So instead of 20, let's do 10. How far would he be? He would be 25. Okay, and let's take half of 30 would be 15, and he would be at 37.5. Half of 40 is 20, and he would be at 50. Okay, so I halved the time. Now let's take and figure out what his rate is now. So Y over X, so that's going to be 25 divided by 10. That is 2.5. So that means he would be going 2.5 meters per second. Well, they want to know how would the graph representing that change? Well, that would mean that 1 would be 2.5, so it would be up here. So the graph is going to be steeper. Okay, how did the table change? The time is half as much. So how would the graph change? The graph would become steeper because he's walking faster. How would the table change? The time is 1/2 of the original. What about the constant of proportionality? Well, the constant of proportionality before was 1.25 meters per second, and now it's 2.5. So is it 2 times faster? It's 2 times bigger. Okay. So now let's do seagulls. Seagulls eat what? Huh. 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Plot a point that shows the number of seagulls and the amount of garbage they ate. Use a straight edge to draw a straight line. So let's start by plotting what we know. Well, we know 4 seagulls ate 10 pounds of garbage. So 4 seagulls, 10 pounds of garbage. We are told it is proportional. So that means 0 seagulls are going to eat 0. Well, how do we figure out what 1 seagull is going to eat? Or 2 seagulls are going to eat? Well, guess what we can do? We can take a straight edge. And we know it's proportional because they told us it was. We can take a straight edge and connect those 2 points because we know 0 seagulls eat. And my straight edge isn't working too well, but that's okay. There we go. So, 1 seagull eats somewhere in here. 2 seagulls eat, does that make sense? If 4 seagulls eat 10, 2 seagulls are going to eat 5. All right, now they want us to know, plot the point 1, k on the line. All right, so we need to figure out our constant because k stands for constant. So if we have 10 seagulls equals, 4 seagulls eat 10 pounds, we want to know 1. How do we do that? 10 divided by 4. So 1 seagull is going to eat 2.5. Well, let's look at it. Here's 1. Is this point about 2.5? It is 1, 2.5. And if we look at this, if I take half of 2, I get 1. What's half of 5? 2.5. So that takes me right down there. All right. So plot the point 1, k. This is 1, k, k being the constant. What is the value of k? 2.5. What does the value of k tell us in context of this story? That 1 seagull ate 2.5 pounds of garbage. All right, so remember the COP occurs when x equals 1. So the COP is when x equals 1, whatever y is your COP. All right, that takes care of this lesson. We're going to look at the summary now. It says, for the relationship represented in this table, y is proportional to x. If we did y over x, we would get 5/4 as the COP. We know that we can write the equation as y equals 5/4 x. We've done that quite a few times. And if we look at the graph if we graph these points right here, 4, 5, 5, 25/4. So they've graphed all those points for us. It is linear, and it goes through the point of origin. So we know that this is proportional by looking at the graph as well. And we can find what the COP is by looking where X is. Whatever the value of Y is what our COP is. So this point right here is going to be our constant of proportionality. The Y value is your COP. All right, so in general, when Y is proportional to X, this is important, the corresponding constant of proportionality is the Y value when X equals 1. So when X equals 1, whatever Y is your COP in the table. When X is 1, whatever Y is your COP. If I make X1 here in this equation, I would get Y equals 5/4 times 1 is going to give me Y equals 5/4, and that would be our COP. All right, so I hope you are feeling more confident with graphs, definitely with tables and equations now, and I will see you on Zoom to do some practice problems.